All right, here we go. We got a new chapter. We're going to dig deeper into some more data here, looking at two sets of data to see if there's a relationship. Don't freak out when you see bivariate data. That just means two sets of data, and we're going to look for these relationships. We're going to start with the frequency tables, and check out the picture there. Don't be confused. That's a table with a lot of C's on it. Some people may say, oh, yeah, there are frequent C's on that table. Maybe not. I don't know. That could be a stretch. Let's take a look at frequency tables. And starting off with categorical data. All right, so what is categorical data? So let's take a look. Back in Mr. Kelly's chapter, we did a lot of things with numbers, like, look at all these different heights, and we found those averages and whatnot. So we're not going to look at specific numbers. We're going to do something like this. Like, we're going to give a survey. So here's my survey right here. Do you like Mr. Kelly's facial hair? Probably the answer to this is no. For me, I'm going to say no. I mean, look at that. That's pretty awful, right? I don't know what that is right there. And then how would you rate your vision? Is it really bad, bad, good, or really good? So we're going to do things that are categories. So do you like his facial hair? Yes or no? And then maybe something like another category could be your vision. So we do this because if we look at these categories, maybe there's some kind of association here. Like maybe people with really bad eyesight actually like Mr. Kelly's facial hair. I think that's probably the only people who would. And we're not saying it causes it, but there may be some kind of association between two categories. So we're going to look at things that aren't specifically numbers, and we're going to analyze data by categories. We're going to collect numbers are collected in groups, so a more realistic survey may be the one below here. So let's say I want to know what kind of soft drink do people like, and then since this is bivariate, we're going to have two sets of data. Then I want to know, are you high school or middle school? So maybe I'm looking for, hey, do most people in middle school like Mountain Dew? Do most people in high school like Sprite? Something like that. So now I say, hey, I'm going to give you the survey. I want you to circle like, oh, man, I really like Dr. Pepper, and I'm a middle school kid. And we're going to compare these two and see if there's any association there. So that's kind of our goal here. Checking out surveys should be pretty fun. Let's get into it. Let's get a lot of highlighter here. Let's say I give that survey about soft drinks there. What is your favorite soft drink? And this is what I collect here. So this is called a two-way frequency table. So I've got two sets of data I've got up here, and let's go ahead and label this. Go ahead and write right on yours. I'm having a pin problem here. Let's label the categories we have. We have categorical data. This is what? Up top here, this is the type of soft drink. So that was in my survey. I said, hey, what type of soft drink do you like? And then over here on this side is what? It's like your age or the type of student you are. And I'm going to try to write sideways. That is really weird. Holy cow. Hopefully you can turn your paper. I can't turn my screen. So this is what kind of student are they? So are you high school or middle school? So, for example, 18 high school kids like Coke, 12 like Dr. Pepper, 4 like Sprite, and 13 like Mountain Dew. So that's my responses. So some more, we're going to have a lot of vocab in here, this one. This response right here is called a joint frequency. So these are joint frequencies. So frequency just means how many times does something happen? How frequent is it? Like those frequencies on the table. And that's anything that falls in this realm right here is your joint frequency. So they all fall into a cell, and it's pretty much that whole table I drew for you. This is your joint frequency area. I think of it like a little prison. They're stuck in these little cells, like they're in a joint. Maybe you don't want to think of it like that. However you want to do it, it's up to you. So we need to add to this. This is great, but it's not really that good. We're going to add to this, and we're going to add a whole nother row here. We're just going to total it up here. So go ahead and total this up. So you're going to have to add on to your little, I started it for you, but I did not finish it. So we're going to add a whole nother column over here called the total column. Boom. Put that in there. And a whole nother row here. Stretch that bad boy out like that. Maybe you got a ruler. Maybe you got better handwriting than me. But we can add these. And since we had joint frequency, this is now called our marginal frequency. Marginal frequency. And it makes sense because, hey, they're in the margins. It's this chunk that we just added here is our marginal frequency. So if I add these totals together, I can add, hey, we got 30 Coke people who like Coke. We got 22 people who like Dr. Pepper. We got 10 here. We've got 41 here. I'm just going to add up in the margins. Then I can add these all up for a grand total of how many people did I survey? Well, there's 52, 62, 103 people were in my survey. Awesome. And then just double check everything over here. 18 and 12 is 30, 34, 47. And feel free to use a calculator. But when you're done, it should all add up here. We got 22, 28, 28, 28, it's 56. So it's 47, 56, 103. It is, so we did it right. So this is a two-way frequency table. Frequency just means how many times it happened. All I did was take my survey and add up all the numbers. So this is pretty cool. I can see, oh yeah, I got 103 people took this survey. I've got them broken up to high school and middle school. It's not bad. 47 high school kids, 56 middle school kids. And then I can see some grand totals here. Hey, 30 kids like Coke, 22 like Dr. Pepper. So it's a pretty cool way to show what is going on with our data here. Let's take it farther. Let's try another survey. So all these are going to be some kind of survey thing. So I'm going to go to generic high school, walk into some random high school, and survey just the freshmen. And I want to, okay, what Wednesday after school activity are you involved in? So let's say I give this survey. I'm asking kids in the hallway or something, and this is the results I get. So my two categories in this case are what is your activity and what are you, male or female? So here's my little two-way table. So I started it, got distracted. Can you finish it? Yes, you can. Yeah, we can finish this because it's all got to add up. So you can see my joint frequency is in here. My marginal's on the outside. So let's start to figure out where can I start. Well, how about right here? I can finish this column right here. 30 plus something is 42, so I know this is 12. And it's almost, I love these. It's almost like a Sudoku puzzle or something kind of fun here. Now I got this row right here, so I can figure out the total in this row by saying, okay, 12 and 26 is 38. Then I've got 42, 52. And then I've got 82, so that gives me the total females. Once I got total females, I can add these together and say, hey, that's going to be 180 total people. Oh, I missed this one right here. Not involved, 50, 30. There's 80. Oh, I could have done band too. 22 total, so there's 34 of them are in the band, so kind of working backwards, there has to be 8 males there. And then now I can fill in these missing 2 here. Let's go with this one, 30 plus 8 plus 50. That puts me at 88, but I need to be at 98, so this has to be 10. And then I can add those together. So a couple different ways to do it. I don't care how you do it as long as you get the right answers. And then make sure everything all adds up. Double check it. Is 42 plus 36 plus 22 plus 80 180? It sure is, so we're good to go there. So I'm going to give you some kind of partially filled in tables just to make sure you can find all those marginal frequencies. Love it. And the missing joint frequencies. Don't want to leave the joint frequencies out. So once you get all that, how many people were surveyed? I actually spelled surveyed wrong. Let's pretend there's not an R there. It's not surveyed. It's surveyed. How many people are students? Well, there's 180 students, aren't there? 180 students that I ran into randomly at the hallway in generic high school. How many of those kids are in math club? So if I go to math club, boom, I've got 36 kids are in math club, 36 students. And then I could break it down even more, like how many males play basketball or something. And I can say, oh yeah, there are 30 out of the 180 are males that play basketball. So this is pretty cool. We got a two-way frequency table. That's pretty good. That's a good start. But I want to take it farther. I want to go into what's called relative frequency tables. So again, I have a frequency table. I'm adding this word relative to it. It's not like a weird uncle or aunt or something like that. It just means in relationship to, like of what you already have. So I guess it is kind of like a weird uncle. It relates to it. So what does that mean? Well, relative to the people that I surveyed. So I surveyed this 180 people. So this is from the last table we just filled out. I had 180 people. So relative to the 180 people, how many of them were male basketball players? Well, remember 30 of them were. So what we're going to do is we're going to take 30, put it over our total, and that's going to give us how many people my relative frequency in this. So we're going to start off with a fraction. And we're going to take that fraction and we're going to go ahead and divide it out. Now what this does is 30 divided by 180 is going to give us a decimal. And this decimal is the probability that if I randomly selected somebody from the survey, I've got a 0.1666666 chance that they will be a male basketball player. So here's how we're going to do this. We are going to round to 3 decimals and we're going to do something that's called truncate. So when I look at this decimal over here, let me pull that back up. I don't care after 3 decimals what is going on. I could care less. Just cover it up. I don't care. I'm not going to round. I'm just going to cut it off. So get 3 decimals and just stop. So it's called truncating. We're just going to cut it right off. And that's going to be our decimal there. So very cool. So we know 30 out of 180, or the probability is 0.1666, that I would randomly select a male from this a male basketball player that was from the survey. Let's finish this out. So we said 12 out of 180 were female. We said 42 played basketball regardless of gender out of 180. Math club, we had 10 guys out of 180 surveyed. We had 26 girls out of 180 surveyed. And we had 36 total math club people. Awesome. So all we're doing is making this into how many out of the total. So we're making these ratios of each cell, and let's just fill these all in together. We're just taking, hey, there was 50 of these out of 180. There were 30 of these out of 180. So it's all relative to the number of people surveyed. And even our marginal frequencies here. So 180. Oops, I messed that one up. Let's try that again. That one was right. But this one, it was 82 out of 180. And then you got 180 out of 180. So let's take some time and maybe grab a calculator for these. It would really help if you have a calculator to go ahead and make these all probabilities. So take a second. I'll do one more with you. All we're going to do is say, hey, there were 12 female basketball players out of 180 students surveyed. So there are 0.066, and we're going to just cut it off right there. Don't even look after that. Don't even try it around. Boom, boom, there it is. In fact, I'm going to change colors so maybe they show up a little bit better. Let's do one more. I got to do one more. Make sure we're good. So let's find the marginal relative frequency. So it's 42 people play basketball after school on Wednesday. So that's going to be 0.233. Cut it off. Go ahead and pause it. See if you can fill in the rest of these, and then unpause it, and I'll have them all done for you as well. All right, there we go. So I filled them in. It's a bit tedious, but hopefully yours match mine. And again, don't be freaked out when you see this vocab. Joint relative frequency. We knew the joint frequency was this spot up here is joint frequency. Now to make joint relative frequency, it's the same spot, but now it's relative to the total. So here's our joint relative frequency. And then if you see marginal relative frequency, it's just the outside. So all we're doing is having relative to this in relation to the total. And then now what's cool, now we can answer some good questions. We can make these percents. So what percent of students are male? So in this survey, what percent are male? Well, I go over to the male row here and find out how many total males. There was 98 out of 180. So 0.544, which is, move that decimal over 2, a 54.4% of them are male. So of the people I surveyed, 54.4% were male. How about this? What percent of students surveyed are females in basketball clubs? So how many are of those? So we come over here to this cell right here. Females in basketball, there are 12 of them out of 180, which is 0.066, which turns, move that decimal 2 places, 6.6%. So now that's kind of cool. We can say other people surveyed, 6.6% of them are females in the basketball club. So now we can kind of get some percents in there, some probabilities to see how often that's happened of the people that I surveyed. Awesome. Very good. Moving on. All right, here we go. Let's check this one out. So I've got a new problem here. Let's say I do a different survey here where I'm curious if people are sharing their computers given their age. So I'm going to ask people, hey, how old are you? And I've grouped them in these different categories here. And do you have to share a computer with somebody else? So it's a yes or no. So I'm interested to see if maybe there's some kind of association going on here between your age and if you actually share a computer or not. So that's our normal two-way frequency table. I already did the survey, threw it in here. So I could go to a relative frequency table. That's what we did last time. That's pretty cool. I'm going to up the ante a little bit here and then do a conditional relative frequency table. So don't freak out. It's like a relative frequency table, but I'm going to add this word here, conditional, and all that means I'm going to add a condition to it. So I don't want to see, okay, out of all the people surveyed, I want to add a condition like, okay, of your age. I want to see specifically, is this condition causing some kind of association here? So given your age, now let's find the conditional relative frequency that you share a computer. Holy cow, so what does that look like? Well, so we've got our two-way frequency table. So now instead of finding out how many people I surveyed, which I totally can, like here it is. I don't know why I left that blank. We can add it together and say, yeah, there are 256 people surveyed. But I want to do it under the condition of your age. So if there were 40 people here, 10 people here, and there are 50 total people, so the condition is your age, I'm going to say 40 out of 50. So people in this age group, there are 50 people in this age group. 40 of them said yes, they should share a computer, if I can talk here. 10 said no, I do not share a computer. And then 50 out of 50 answered it. So if you check out what I'm doing now is I'm making these probabilities for each column here. So let's try another one. So I said there are 47 of these. 25 said no. There are 72 total people. So 47 out of 72 said yes, 25 out of 72 said no. Boom, I can make my relative frequency from this. So I'm adding a condition. I'm not doing the total this time. So 16, 17-year-olds, 42 of them said yes, 36 said no. There are 78 total. So 42 out of 78 said yes, 36 out of 78 said no. And same thing here. I can go 22 out of 78. Oh, 78. What is going on here? How about 22 out of 56 people said yes. 34 out of 56 said no. And then I got this. So I can do this bottom row all day. I know this is going to be 100% or probability of 1. That's going to happen. When I get over here, this is a weird marginal. There's no real condition, so these actually will be out of the total. They're not really conditional because they're just total. So when I do these conditional, those just kind of fill themselves in. It's this column that I'm actually looking for. So I know 4 out of 5, I can do that one as 0.8, and I know this one is 0.2, and that gives me the total of 1 there. Real quick, if you want to fill in the rest, try it, pause it. All right, there you go. So I went ahead and filled them all in. Hopefully you got those same probabilities. So what's nice about this, suppose I randomly selected a person, and that person is 15, so they fall in this category right here. So it's kind of like given a student's age. Given the person I randomly select is 15 years old, do you think they share a computer? Well, that's good. It's kind of hard to see from up here. I can see 47 out of 256. But what if I've given this condition? Okay, I know they're already here, so that's given. Do you think they share a computer? I would say, yeah, chances are. Why? Because 65.2% of them actually share a computer. So I would be inclined to say, yeah, I think they do, because over half of them do. Probably 65.2% would actually share a computer. So that's what's nice about this. So that's pretty cool. Also, we can do it the other way. So if I have the same information and I want to say, okay, what if I look at the survey and say, okay, given this student shares a computer, can you find the conditional relative frequency of their age? So it's kind of the opposite of what I just did. So instead of doing it by columns, I can do it by rows. So sometimes it's advantageous to do it by rows. So in this case, I can say of the people who said yes in this, I can say there are 40 out of 151 people who said yes. So this is out of the people who said yes. I'm only interested in people, okay, who's sharing computers? Well, 47 of the 151 are in this age group. 42 of the 151 who said yes are in this age group, and 22 of the 151 are in this age group. And then now I can do it for the no's. No's, I had 105 no's. 10 of them were in this one. 25 of the no's were here. 36 of the no's were here. And 34 of the no's were here. And then I can say, I love filling this one in. That's just the total. 105. So these are going to be our probability of 1 or 100%. And then this is the part that's kind of weird of this one that's we're not really looking at. So it just goes over the total, which I believe was what? Was that 256? If we total those all up, 72 out of 256, 78 out of 256, and then 56 out of 256. So that kind of marginal frequency, conditional frequency doesn't matter for us. In this case, it's this joint conditional frequency we're looking at. And so why would I want to do this? Well, real quick, I'm going to magically turn these into percents. All right, there they are all filled out for you. So now we can answer a question like this. Suppose you select a person at random. So I randomly pick somebody from my survey. And if they share a computer, so I know that they share a computer. So it's given they share a computer, how likely are they to be 16? So they share a computer, yes. This is going to be this conditional relative frequency right here. Boom, there's a 27.8% chance that they are in the 16 to 17 years old, given that they said yes. So that kind of sums up why do we do this? Well, we're kind of looking for associations. Something like, does your age, is it associated to the fact of do I share a computer? So is there any kind of association here? So if I kind of go back and look at all of these, I'm just going to look at the percents or the probabilities here. So if I look at these, is there any kind of breakdown of people who said yes? So 26.4, 31.1, 27.8, 14.5. Can you see what's happening here in these? I mean, I could make a nice little bar graph like Mr. Kelly did last chapter. 26, 31, 27, 14. It looks like as they get older here, this especially right here, this is where it seems like there are less of them sharing. So when you hit 18, 19, it looks like a pretty decent drop in who has to share computer. So that's pretty cool. And then probably, I imagine the thing, it'll show up the other way. Are you sharing a computer? We've got these percents right here. Boom, boom, boom. Can you see any ones that are, we're looking for ones that are considerably different. Share a computer. No, these 12 to 13-year-olds not sharing computer. There just aren't that many of them. There aren't that many of these guys that aren't sharing a computer. So when you're younger, you got to share. When you're older, you're not. So we're looking for that association kind of there. So that's why the conditional is so important to kind of build that association. It doesn't mean that if you're young, you have to share a computer. It just means you're more than likely to, from our survey, maybe there's some kind of association between your age and sharing. Awesome. So I threw a lot at you right there. Let's see if we can sum it up real quick. And then I just want you to practice these. Practice, practice, practice. If you're still not getting it, do the corrective before you take that master check, just to make sure you got this all figured out and you're good to go. So in summary, you give a survey like, hey, what's your main social media here? Facebook, Twitter, or Snapchat? And then are you old or young? So we've got something going on. Boom, you build your table. We got a two-way frequency table here where I just wrote down everything, counted those numbers. So 72 people took the survey. I forgot the titles, rookie. So this is your social media right here, your type of social media. And then this is just your age right here. Boom. Are you old or young? So 72 people took my survey. So this is cool. I can answer questions like, hey, 10 young people use Twitter in my survey. So that's pretty good. Or overall, 34 people used old people. I can't even talk. There were 34 old people in my survey. Or I can say something like, hey, 20 people use Facebook. But look at the difference. So we really got to break it down, look for these differences. Relative frequency tables can help us do that. Great segue right there. If you look at all the people surveyed, 25% of them are old Facebook users. Old people like Facebook. Look at the young people. Very little the young people use that as their main social media. So there's a big difference. But this is relative to everyone who took the survey. So this is, again, 25% of all the people who were surveyed. So if you want to dig even deeper, that's when you got to break it down and get into this conditional. I think I got it up here somewhere. There it is, relative frequency table, where I can say, yeah, given you're old, what are you going to use? Well, given I'm an old person, like myself, I'm going to use Facebook, 52.9%. Some old people do like Snapchat and Twitter, but mainly this is their main one they use. Versus young people, you can see, oh yeah, overwhelmingly, there is an association between your age and your social media. Young people 68.4% of them really prefer the Snapchat. Well, if you look at old people, they prefer the Facebook. Awesome. That is it right there. Good luck on that. I hope this goes well for you. Peace out.